I have I will record the session. Okay. Okay. So this is our topic, analyzing the microwave networks. The network means circuits. Okay. This is circuits, not microwave links or something. Okay. So this is referred with the microwave circuits. Okay. So if you consider microwave circuit, okay. If you consider microwave circuit, okay. So can you tell me what are the equipment we will have there? Can anyone tell? Tell me some equipment or component in a microwave circuit or communication circuits. What are the? There are some popular components. Can you tell me one or two? Consider your phone circuit. Okay. So you have, I think all of you have my, yes, very good. Okay. So, uh, so if you consider your mobile phone, okay, so that is operating around 2.4 gigahertz. Okay. When you are using 4G, okay, 4G LTE, it is working around 2.4 gigahertz. Okay, so this is a microwave frequency. So this is a lower microwave frequency. Okay, so if you consider your phone, the circuits and the components should support the microwave range. Okay, so if you consider circuit, so there are many popular components. Okay, for example, you will have oscillators. So you know what is oscillator? Okay, so normally oscillator will give you a signal, no? Sinusoidal or some kind of wave. Okay, oscillators. Okay, then sometime you will have amplifier, filter, okay, and coupler, antenna. So there are many components available. Okay, so if you consider oscillator, you know that the oscillator can be made up with transistor. Okay, so there are many type of oscillators available. Okay, crystal oscillators, transistor oscillators, several oscillators are there. Okay, so anyway, you know that normally oscillator will give you a signal. No? It may be a sinusoidal signal. Okay, it may be a sinusoidal signal, or it may be a rectangular signal like this. So this kind of signals you can get from the oscillators. Okay. An amplifier, you know that, for example, there are transistor amplifiers. Okay. So using the transistor, you can make amplifiers. No? Okay. Okay. So amplifiers are there. This kind of one. Okay. So once you give a signal, input signal, so you will get the amplified signal. Okay. If the signal is like this, you will get the amplified signal as output. Okay. So the filters are there. Okay. So there are many type of filter, actives and passive filters. Okay. So filter also there. Okay. So you have the input and you have the filtered output. And the couplers. Okay. Coupler means sometime you can split the wave into 2 or 3 section. Okay, like this. Okay. So if you input the signal, okay. So here you will get a portion of this signal. Okay. and there is another portion of this signal. Okay. So once you combine them, X1 and X2, you will get the input signal. Okay. So if you send a signal, you can couple it, one portion from this line and one portion from this line. Okay. So this is a coupler. Okay. And also combiners are there. Okay. So if you send two signal, okay. If you send two signal, let's say that X1T and X2T. So you can get the combined output signal. Okay. So these are combiner. Okay. So these are splitter combiner. Okay. And antenna, you know that if you feed the signal to the antenna, okay. If you feed the signal to the antenna, so it will transmit. Okay. So these are the circuits available. Okay. So if you consider this component, okay, these are component actually. Okay. So if you consider this component, okay. So you can see if you consider oscillator, okay. Oscillator, once you give a power supply to the oscillator, once you give a power supply to the oscillator, if you power on the oscillator, it will give a signal. No? It will give the desired signal. Okay. So you have to power on the oscillator, then it will give output. Okay. So only one connection you can get the output. Okay. So we called this is as one port device. This is a one port device. Only one port is available for the oscillator. Okay. So once you have given the electricity, you will get the signal. Okay. If you get the signal, okay, normally port refer, we have discussed these things in the interaction session. Okay. The port means the connector that is used to input or output a signal. Okay. Connectors that is used to output or input the signal. Input the signal, okay? Information. This is actually information. Okay. So that is normally referred as a port. Okay. So the power connector is not a port. Okay. Power connector is not a port. If you consider your laptop power connector, it is not a port. Okay. So normally we are not referring power port. Okay. It is just a power connector, not a port. Okay. But some informations are transferring in or out from the device, that is a port. Okay. So this oscillator has only one port. Okay. Because other one is the power supply connector. Okay. And how many port has this amplifier? Can you tell me? How many port this amplifier have?
2 ports.
Yes, it has 2 ports. This one is a 2-port device. Okay. So the oscillator is a 1-port device. This amplifier is a 2-port device. Okay, so this amplifier also, the transistor also should be given a VCC, no? Okay. So, but that is not considered as a port. Okay, that is not considered as a port. Okay? Only the signals in and signal output connectors are considered as port. Okay, so this amplifier has only 2 ports. Okay? So how many port filter have? It is also 2 port, no? Because you should input the signal and you can get the output of the signal. Okay, so it is also a 2-port network. Okay, so how many ports this combiner and splitter have? Yes, 3 ports, sometime more. Yes, very good. Okay, so this is a 2-way coupler or 2-way splitter. Okay, if it is a 2-way splitter, you will have 3 ports. Okay, 3 ports. Sometime you will have 3-way splitters. That means your signal is divided into three parts like this. Okay. So you have output, three output, one, two, three output, and input also there. So there are altogether four ports. Okay. So coupler will have three or more ports. Okay, three or more ports. Okay. How many ports this antenna have? Yes, it has only one port. It has only one port, no? Okay. So you can see that only one port is available. You feed the signal to that port. Okay, so that is the input. If it is a transmitting antenna, it is the input port. If it is the receiving antenna, it will be the output port. Okay. If it is the transmitting antenna, it is the input port. And if it is the receiving antenna, it will be the output port. Okay. So only one port is there. You are feeding the signal through it. Okay. And then it will be coupled to there. So there is not any port. Okay. So antenna has only one port. Okay. So if you consider, okay, this microwave component has several ports. Okay. It may be one port. Okay. There may be one port, two port, three port, like this. Okay. Okay. For simplicity, we will consider a two-port network. Okay. So these components are normally referred as networks. Okay. If you consider this oscillator, the oscillator should have three or more transistors. Okay. At least two transistors. At least two transistors you need to make this oscillator. So it is the interconnection of device. Okay. Some devices or components are interconnected. Okay. The transistors and resistors are interconnected to make this oscillator. So it is a network, no? If you consider this amplifier may have only one transistor, but you should have some resistors, no? Resistors, and you should have some capacitors. Okay. So again, it also interconnection of some device, no? Capacitor, resistor, and transistor. So it is also network. Okay. So if you consider filter, there can be various filter, LRC filter. Okay. And op-amps filter, active filters. Okay. So anyway, you can see that here also there are some components and they are interconnected. So those are the networks. Those are also considered as a network. Okay. So if I consider two-port network, okay, if I consider two-port network, can you give me one or two examples for a two-port network? We have seen above. Can you give one or two examples for a two-port network? Yes, amplifier, filter, yeah, filter. Those are two-port network, okay, amplifier, filter. So that kind of a two-port network. You have two ports, okay. You have basically input port, okay. So this is the input port, okay. And you have the output port. You have the output port, okay. Input and output port, okay. So these are electrical circuits, no? These are electronics or electrical circuits, no? Okay. So these are normally we are providing voltage and currents to operate. Okay. For example, if this is a filter, okay, the input signal means the voltage signal. Okay. The voltage is varying with time. Okay. So you are giving a voltage signal. Okay. And the output is also voltage signal. Okay. If it is a filter. Okay. So let's say that your input voltage is V in, okay, and the output voltage is V out, okay. So there should be a current flowing to the device, okay. So that will be the input current, okay. And there is output current also, okay. There is output current also. Actually, we are normally marking that output current in this direction, okay. I out, okay. So this is the output port and this is the current available at the output, okay. So normally we mark this current this way, okay. So sometime, most probably the current may be out from the device, okay. If it is coming out from the device, so it will be a minus current, okay. If a current go to the circuit, it will be a plus current, okay. So normally uh, we are marking the current in this direction, okay. Okay, and also you know that this is the V in, V out, and also you know that, okay. So if it is a filter, okay, if it is a filter, okay, so you have to, so there is a signal coming through a transmission line maybe, okay. So this transmission line should be connected to the filter, okay. Transmission line should be connected to the filter, okay. So if it is a filter amplifier, okay, you should connect the input signal from a transmission line, okay. So you know that if this transmission line impedance is not matched with the filter impedance, sometimes signal can be reflected, okay. So there can be some reflected wave also, reflected voltage and current. V reflected and I reflected, okay. Here also, once the voltage, the signal is to the signal, okay. Once the signal is output to another device, it is also going through a transmission line, okay. So if this output transmission line is not matched with the output port of the filter, there can be a reflected waves, okay. So if you consider two-port network, there are some parameters, no? Some voltage and current values, input and output, okay. Input and output current and voltage, reflected current and voltage, okay. So based on these parameters, we can define some another parameters, okay. For example, if you know that uh, V is equal to IR. This is the Ohm's law. So this R is a resistor. Okay. So if you have any reactive or that means if you have capacitor or inductor, okay, if you have capacitor on inductor, so this resistor value will not be a real value, no? So you know that these resistors are real values. These are real values, okay? But if you have some inductor and capacitors, this is not a real value. It will be a complex value, okay? It will be a complex value. If capacitor and inductors available, okay? So this resistance will be a complex value. Normally we call this as impedance, okay? This is normally we called as an impedance, okay? So if you have a resistor, it is a real impedance, okay? If it is a resistor, It will be a real impedance. Impedance means the resistance, okay? But it is not referred the normally resistor we referred as for the real impedance, okay? But if we have cap O inductor, you will have a complex impedances. Complex impedances. Normally use Z to denote. Okay. We will discuss this later, okay? Up to now, please keep this idea. Okay. So anyway, if you have capacitor and inductors, this should be a complex impedance, okay? So it is like this, okay? V equal IZ, okay? So this Z is a complex impedance, okay? So here it may be not only resistor, but it can be capacitor inductor integration, integrated with capacitor inductor, okay? So this is called as impedance, okay? So what I want to tell you is that if you got V divided by I, so you have get the impedance, okay? So if you consider this circuits, okay? If you consider this circuits, so I will write it here again without considering the reflection, okay? I will write that system again here, and I am not going to consider the reflection voltage, reflected voltage, okay? So I just mark the input voltage, input current, output voltage, and output current, okay? So then tell me, using these voltage and current values, how many impedance value can you define? How many impedance value can you define? Yes, very good. I got 2 answers. Okay. What about others? How many impedances value we can? Yes. Actually, we can define 4 types of impedance value. 4 types of impedance value. Okay. Okay. Because there are 4. So you have 2 voltage and 2 current. Okay. So you can get V in, I in. This is referred as input impedance. And you can get V out, I out. This is referred as output impedance. Then also you can get V in, I out, and V out, I in. Okay. So altogether you can define 4 impedance. Okay. So you can define this impedance using a matrix. Okay. You can define these 4 impedance using a matrix. Okay. So you can write here the input voltage. Okay, so you know that V is equal to IZ. Okay, okay. So you can define the V matrix. Okay, voltage matrix. You can define a voltage matrix, and also you can define a current matrix. And this will be the impedance matrix. So this is the impedance, no? This is the impedance matrix. So you can define a impedance matrix, okay? So you have 2 type of voltage, V in, V out. So in this matrix, you have 2. So if you consider the voltage matrix, okay? So that matrix will have 2 voltage value, V in and V out. If you consider current matrix, okay? if you consider current matrix, okay, so normally you are using this kind of bracket to emphasize these matrix, okay. So if I write here, the voltage matrix is equal to I is equal to Z, okay. So this is called as impedance matrix. This is the impedance matrix. So this current matrix, you will have again two currents, no? I in and I out. I in and out. So using this current matrix value and impedance matrix, you can define four type of impedance. Okay, four type of impedance. Okay, so I think now you can understand how we can represent in this matrix in a matrix form. Okay, so you have two voltage. Okay, so normally you will use you should use a column matrix to define, to show the current voltage is equal, and you have also two current matrix. Okay, so I will put my Z parameter here, okay, and you will have two current matrix also, I in, I out. Then you will have here four impedance matrix. Okay, so normally we referred it as 1, 1. Okay, so this first one refer the column number. Okay, if you consider this one, okay, set 1, 1. This is the column number. Sorry, row number. This is valid for every matrices. Okay, if you have any Z, let's say that X, Y. This X means the row number. Okay, and this is column. This X is row number and Y is column number. Okay, so you have two rows and two columns. Okay, rows means these are rows. Okay, and you will have two columns also. Okay, so this is the first row, this is the second row, this is the first column, this is the second column. Okay, so you have two rows and two columns. Okay, so this first one means the row 1, 1. That means first row, first column. So what is this one? Is it 1, 2, no? First row, second column. First row, second column. So what is this one? Can anyone tell? This is what? Yes, that is Z21. Okay. Yes, that is Z21. That means second row, first column. This is the second row, this is the first row, and this is the second row. Second row, first column, 2, 1. So what is this one? Yes, that is Z22. Okay. So actually, this is the impedance matrix. Okay. So for a two-port network, okay, for a two-port network, you can define, okay, you can define the impedance matrix as, okay, first you have the voltage matrix is multiplied by, this is your impedance matrix. Okay. So this is the impedance matrix. Okay. So you can denote this. Okay. So you can write the equation using this one. Okay. So normally how you multiply, how you solve this matrix. Okay. So definitely this should be a square matrix. Okay. That means the columns and rows should be equal. Columns and row should be equal. So, okay. Otherwise you can't multiply this. Okay. And normally the number of rows of these matrix should be same. This voltage matrix, impedance matrix, current matrix, the number of rows should be equal. Okay. So you can simplify this. Okay. Actually, V in is equal to, you can multiply this Z11, I1 from I in. Okay. Z11, I in plus Z12, I out. Z12, I out. Okay. And also you can write V out is equal to, now you have complete this row. Okay. Now you have to write this row. V out is equal to Z21, I in plus Z22, I2. Okay. So you can write the equation like this. Okay. Okay. Now we will do an example. Okay. So I think this is okay. So if you have any question, please ask me. Okay. This is how we can solve this matrix into an equation form. Okay. Are you okay with this? Are you okay with this? Okay, thank you. Okay, now I will give you one example. Okay. Okay. If you have a three-port network, okay, like this, okay. So it may be a three-port network. So this is the first port, okay, and you have this kind of one network. This is the second port, and this is the third port, okay. So this is the input port, and this is the output port 1, and this is the output port 2, okay. Let's say that current and voltage for this one is V1, I1, okay, V1, I1. This V2, I2. This V3, I3, okay. So how many impedance you will have here? How many number of impedance you will have? Yes. Very good. What about others? How many impedance we have? Yes. Okay. Now try to write the matrix, the impedance matrix for this one. First, you have to write the voltage matrix. It should be a column matrix. And that should be, and it is equal to, and you have a Z matrix, okay? So first you have to draw the voltage matrix, okay? So it will be a column matrix, okay? So you have to put the voltage value here, okay? And it is equal to, then you have the Z matrix, okay? Then normally you have the Z matrix, okay? actually this is impedance, no? This is impedance, no? So this is also called as impedance matrix, okay? So this is a sometimes referred as is a parameter, okay? Or impedance parameter, okay? Impedance parameter. Then you will have a square matrix, okay? So number of columns, okay? Number of columns should be equal to the number of rows. This number of rows should be equal to the number of columns. Then you have the current matrix here, okay? So how many voltage are here in this network? This is the three-port network. How many voltage are? Yes, 3 voltage. What are the voltage? V1, V2, and V3. These are the voltage we have. What are the current we have? What are the current we have? Yes, I1, I2, I3. Okay. So we have current I1, I2, I3. Okay. So you can see that here we have 3 columns, 3 rows. Okay. This is first row, second row, third row. Okay. And first row, second row, third row. So this should be a square matrix, definitely. Okay. So you should have also 3 columns. Okay. 1 column, second column, third column. So you will have altogether 9 values. No? This one should be Z11. First row, first column. This one should be 1, 2. First row, second column. This one should be 1, 3. First row, third column. This is second column. This is second row. So second row, first column. Second row, second column. Second row, third column. This is third row. Third row, first column. Third row, second column. Third row, third column. So altogether you will have 9 values. Okay. So I think you can write the equation for the voltage and currents equation. Okay. So if you consider this one, first row, this row, okay, you can write V1 is equal to Z11 I1 plus Z12 I2 plus Z13 I3. And for the second row, you can write V2 is equal to Z21 I1 plus Z22 I2 plus Z23 I3. And what is for V3? It should be Z31 I1 plus Z33 I3 plus Z32, okay? Z32 I plus Z33 I. This should be I2. Yeah. Okay. Okay, I2. Okay. So this is the Z parameter, okay? And we will stop here, okay? We will stop here. You have to actually discuss another 2 type of parameters, okay? A, B, C, D parameter and S parameter, okay? So we will discuss it in coming week, okay? So we will stop here because you have the IoT lecture, no? Okay? So we will stop here. You can join with that one, okay? So if you have any problem, you can ask, okay? So we are considering the impedance matrix here, impedance parameter, Z parameter, okay? So this is the matrix for the Z parameter, okay? And I will give you one question, okay? Try to do it at home, okay? So if I give you this kind of one, Okay, let's say that this is C, this is L, and this is R. Okay, and uh, try to find the here for this network. For this network, try to find the Z parameter. Z parameter. Uh, let's say that the frequency of this circuit is F or something. Okay. If the frequency of this circuit, let's say that FC or something. Okay. So try to find the Z parameters for this network. Okay. So you have, this is a two-port network. And to find that one, okay, to find that one, you have to use this identities. You have to use this identities and try to find it. Okay. So you have to do some techniques. Okay. So practically you are going to measure it. Okay. So anything you can do, any practical things you can do. Okay. So you can give a non-signal, non-voltage, and you can measure the voltage here. Likewise, you can do any practical things. Okay. To these circuits. Okay. So you can make the assumption and approximation and try to find the Z parameter. Okay. So tomorrow we will try to do this one. Okay. Okay. So try by yourself first. Okay. Okay. Thank you. Yeah, we will have the physical lecture. Okay. We will have the physical lecture tomorrow. Okay. Then I will stop. Okay. If you have any problem, you can ask me.